And welcome back to another episode of Containers on the Couch. Olly, it seems like pretty much yesterday or not so long ago that you were on the show, but welcome back. Also, I would like to welcome our other guest, Himanshu. Can you please introduce yourself, tell us who you are, what you do in AWS, and where you are with that beautiful background behind you?
Thanks for the introduction, and thank you all for joining. I'm a senior PM in the AWS Fargate team, and I'm right now in Glacier National Park. It's a good sunny afternoon here, and yeah, happy to be on this live broadcast.
And Olly, please introduce yourself for those who don't know who you are.
Yeah, absolutely. So, hey, everybody. My name is Olly. I'm a developer advocate here at AWS. I work in the AWS Fargate team and do work on Fargate and things at the container runtime. And this green background behind me is the London office.
And my name is Mesado Casing, and this background behind me is actually a green screen, so you can see behind with the shadows, but a nice background which we use for our episodes over here. I'm a developer advocate with the ECS service team, and today we are going to be talking about Sochi. Correct? That's how you pronounce it?
Correct.
Perfect.
So we had a release last week of something which uses Sochi, but that's actually not the feature which we released. So what did we announce? And can you tell us a little bit more about it and why is it good for our customers?
Sure. Last week, we announced AWS Fargate support for Sochi, which is short form for Seekable OCI. So what it does is, it enables ECS applications to run faster, and that looks like a magic, but there's a ton of engineering behind this. So just to set the context right, just to give a hook to the conversation. So we launched the private preview a few months back, and we had a good number of customers testing it out, and we had an overwhelming response from the customers. We launched, along with the launch, we had a launch blog coming out. And in the launch blog, in the bottom, you can see some of the customer codes. And the task improvement numbers were phenomenal. We saw a customer reporting 40% improvement in the task startup, 60% improvement in their other task startup, and then 50% improvement in their startups. It works for various different use cases, starting from AI/ML to CI/CD pipelines, Java applications, Python applications, data science applications, and a plethora of different applications. So the numbers are very good, we are seeing, and I'll let Olly take over from here and then maybe introduce a bit of the architecture behind Fargate and EC2, and then I'll introduce more on Sochi then.
Yeah, cool. Thank you. So as Himanshu just kind of spoke and introduced, we announced Seekable OCI support within AWS Fargate. And before kind of jumping into Seekable OCI, how it works, how you can get started with it, I wanted to talk a little bit about the problem statement on why, I guess, container image pulling and start times are such a focus area for Fargate customers. The diagram on the screen here shows the two different compute models that are available to customers that run on Amazon ECS. On the left-hand side, you have tasks that run on EC2. Sorry, on the right-hand side, you have tasks that run on EC2. And on the left-hand side, you have tasks that run on Fargate. And one of the key fundamental differences here is that when tasks run on Fargate, and a task is an ECS construct of multiple containers scheduled together. So you might have an application code and some sidecars for monitoring and logging. When you schedule those together as a task, on EC2, they often get scheduled together. So if you had multiple replicas of maybe like a web server or something, you may end up with multiple replicas on the same host. Whereas with Fargate, that is never the case. In Fargate, we have a strict isolation boundary. Every time you run a task, it runs on its own dedicated machine. Single use, single tenant. So that machine has never run a container before. It will run your task. When your task is ran, that machine goes away and will be removed. And so you kind of have this life cycle problem on the Fargate side that you don't have on the EC2 side. And that lifecycle problem is every time you want to run a task, the machine hasn't been used, we have to go and download the container images. And as we've kind of seen, and Himanshu will talk about, container images are getting bigger and bigger. And the larger the container image, the more time it takes to download. And therefore, maybe the slower your task starts when running on Fargate. When running on EC2, less of a concern. You could do lots of different things to speed that up. You could preload all of the container images onto your EC2, or if you are running multiple replicas of the same workload, then you only have to deal with that downloading, pulling pain once, and then the second and third task will be able to reuse that existing image that lives on the box. So yeah, that's kind of like the higher level architecture. Himanshu, do you want to kind of give a bit of a background on I guess, container images and some of the interesting research and ways to pull container images?
Thanks, Olly, for the introduction. So let's take a step back. Let's start from the very beginning, how it all started. So the way I explain the task startup time is, like, for the sake of simplicity, let's say it's divided into two parts. The first part is what I call the infra or the container setup, where the underlying hardware is provisioned, and then the entire container image is downloaded before moving to the next stage. The second stage is the application initialization stage, where once the entire image has been downloaded, your application sets itself up, initializes its framework or skeleton before actually starting the application requests or the workloads. Now, there was an interesting paper that was published a few years back. Let me just put out the link of that paper. So what that paper suggests that 76% of the entire task startup time is because of the image pull. But contrary to that, only 6.4% of the image file is actually needed for the application to start doing useful work. So what does this mean? This means that the other time that you're spending to download the entire image is redundant, and we can actually get around that time. Now, obviously, there are some other interesting ways to improve your task startup time or container startup time, and one is obviously caching an image. But the other way is lazy loading the container image, which actually takes advantage of this fact that only 6.4%, or let's say a very small amount of files, are needed for application to start doing useful work. And what does lazy loading mean? So let's for the time being, before Olly jumps later into the deep dive into this, let's say lazy loading is some magical mechanism which somehow bypasses or skips the container image download time, and then skips directly to the application init stage, where now you have just skipped that download time. Now you can just the mechanism just pulls lazily or on demand the file which is actually needed by the application to build its skeleton, to initialize itself before starting serving the requests. And that's it. You have saved all the redundant steps here because of this magical mechanism. And now, but like everything comes at a cost. So there are a lot of interesting projects out there, such as StarGZ, which takes advantage of this lazy loading, or which actually is a kind of a lazy loading mechanism. But the cost here is that you have to enable lazy loading. You have to convert the image format. But our customers have very sophisticated CI/CD pipelines. So this means for image conversion, you have to modify your CI/CD pipelines, and which is tons of effort. Along with this, when you modify an image, this means the SHA of the image is no longer valid, which creates problems in image security mechanisms such as image signing and others. And we Amazonians are customer obsessed. That's what from day one we are. And now we took it on ourselves that we have to solve this problem for our customers. And this led to the Sochi project and all the brainstormings. It gave me even mentioning this conversation gave me goosebumps, because it takes me back to the conversation, that tons of whiteboarding sessions we had around solving this problem. And this is where Sochi or Seekable OCI comes into picture. So as we have been talking about lazy loading, so Sochi is obviously a lazy loading technology, which works by creating a Sochi index. You can metaphorically say or visualize Sochi index as kind of a hash map of an image, file location, and its name. Though it's not exactly that, but just for the sake of visualization. And now that this image index or Sochi index is built and then pushed to the image repository as a separate artifact. And since it's a separate artifact and built separately from the image, this means the image is not converted. It remains as is. This means its SHA is not changed. Its SHA remains same. All the image security mechanism will still work. And the another beautiful thing is, like, as I mentioned, customers don't want to change their CI/CD pipelines. And this is where we also along with the CLI tool, which can be embedded with the CI/CD pipeline, we came up with another mechanism where customers don't need to change their CI/CD pipeline, and building this Sochi index works out of the box without impacting any of their pipelines, any of their images. And that's where we kind of solve the second part of the customer problem. And I'm glad to share that we open sourced this technology last year in September. And now, last week, we integrated this technology with AWS Fargate for applications, for ECS applications. And let me share the GitHub link of Sochi as well. So I would highly encourage all you to look into the GitHub project. It's an open source project. We are very much following this, and please feel free to comment on the issues that we have in the GitHub project, so that we can hear your voice. We can incorporate all those changes, and feel free to also contribute to the open source project as well. So coming back to the AWS Fargate, improving the task startup, ECS task startup times. Using Sochi, I'll now request Olly, my colleague, to take over and explain all the things that I said one after the other in more detail.
Yeah, absolutely. Yeah, awesome. Thank you very much for all of the background. Yeah, it's there's been so much going on the Sochi side, so it's awesome for us to get this opportunity to talk about it and show you guys what Sochi is and how it works. So just picking up on a few of the pieces that Himanshu talked about there. So yeah, last September we open sourced the Seekable OCI, or the Sochi snapshotter project on GitHub. So if you go to the link that Himanshu has just shared, you will be able to see the Sochi snapshotter. Your first question will be probably, what is a snapshotter? And so for those that are familiar with container runtimes or have used the Docker engine in the past, the snapshotter is the part of the container runtime that handles the file systems of a running container. When in the Docker engine world, these were called graph drivers. So you may have heard of these things called like overlay 2 or device mapper as the graph drivers inside of the Docker engine. Inside of containerd, they are not called graph drivers anymore. They're called snapshotters. So what the Sochi snapshotter is a bit of technology that you can plug into containerd, and you can tell it to manage the file system of your running containers. That's where that bit comes from. That's where you'll see snapshotter everywhere, and why the GitHub project's named the way it is. So a few diagrams maybe to help talk about what Himanshu just talked about. So the first thing we want to talk about.
Olly, sorry, 1 second. I'm going to ask you to make that bigger for the viewers on the screen, if that's okay.
Oh yeah, for sure, absolutely. I'll do that. So this is a deep dive blog. This deep dive blog went live last Tuesday, and in it you'll find all of the like under the hood definitions of Sochi, how it works, how indexes work, how it lazy loads, and things like that. But there's some really cool diagrams in there that help you understand how the technology pieces together. So for those of you who have used containers before, you'll know that you build a container image, you push a container image up to a registry. Well, what you're actually pushing up to a registry is you're pushing up something called a container image manifest, and you're pushing up a number of file system layers. The file system layers are compressed tarbles, so they'll be like tar-g zips. And you'll have loads of those depending on how many layers is in the image. Like every time you put a new line in a Docker file, you get a new layer. And then the manifest basically is the document that references all of the layers and has a bit more information around what that image was built for. So that's what's on the left-hand side of this diagram. That's been around now for quite a long time. It's been standardized by the OCI. Container image manifests are pretty common static things. And as Himanshu was talking about, lazy loading technology isn't something that was new. There's been a few other projects that have been involved in lazy loading container images. The CRFS project from Google did some great work, and then that was built upon again by the StorageEZ project, and now built upon again with Seekable OCI. But one of the things we wanted to do with Seekable OCI is we didn't want to change the left-hand side of the diagram, because the second you start to change it, the digests start to change and build processes start to change, and it introduces, I guess, a lot of complexity for customers. And so what we wanted to do is we wanted to be able to create an inventory of everything inside of a container image and store it next to the container image. Rather than storing it in the image, we wanted to store it next to it. And that's what we do with Sochi. We create something called a Sochi index, or a Sochi index manifest. And we'll talk all sorts of ways around how you do that and how you generate one. And we'll have some demos in a little bit as well around how we can generate one. But the Sochi index is another manifest that you store in a registry. So alongside your container image, you'll have a Sochi index. And for every layer in your container image, so for every compressed tarball, we'll have a ZTOC, or basically a table of contents of what's inside that layer. So in the left-hand side here, you can see that there's a load of files inside of the tarball. And on the right-hand side, we have a ZTOC that says, yep, here are all the files. And here is the exact position inside of that, or the offset where that file lives inside of the tarball. And so you now have this I guess, you have all of your files on the left-hand side, and on the right-hand side, you have a map. So somebody wanting to find a file will know how to do it.
So I have a question.
Yeah, go for it.
See if I understand it correctly.
Yeah,
because we're not getting very much participation from the chat today, but that's okay. We're only streaming here today on YouTube, not on Twitch for a change. But my question on this is the following. Yeah. From what I understand, you're saying, for example, if we look on this diagram, you've got 3 different layers, which they correspond, for example, to 3 different commands which were added into this container image. For example, on the first, if I could look at the container image layers, the first layer has the ls command. The second one has the passwd command. The third one is the apt command. How does the container, or the actual container, know when to pull each one? I know we have a manifest which points to each one of them, but how does it understand that now I have to go and pull the specific layer which is used for apt, and now I have to pull the specific layer which is used for passwd? How does it work? Or am I not understanding correctly?
No, that's basically what we're talking about, absolutely. And how that works is that this now brings in that snapshotter piece. So once you generate an index, you're then good to go with the snapshotter. Now, the snapshotter is the piece that lives on the server where you're running your containers. So this is what we open sourced back last year, and what we announced last week that we have bundled inside of the Fargate data plane. And so there's a second diagram in the blog, which will hopefully help answer your question a little bit there, Mesh. So,
and I'm going to ask you to make it still slightly bit bigger, because even from here, I can't really see it properly.
Yeah, absolutely. No, it's okay.
Yeah, that's better.
Okay. So there's a few more pieces, and I forgive me for introducing lots of new terminology for those that may be new to containers, or at least new to container runtimes, because this is some of the plumbing, I would say. But this is all in the blog, so feel free to read it again and watch this back again, and hopefully it pieces together a few more times. But yeah, so in this orange box, you have your containerized application. So this is your workload. And every time it tries to talk to, or it tries to access a file or write a file, when you use Sochi, we put something called a fuse file system, or a user's file system in user space, which is what fuse stands for, on the server. So the application talks to fuse. If the file does not live on the server, and so it may already live there because someone's tried to access it before, but let's say that it doesn't, and in your example, it's not there. What the Sochi snapshotter will do is it will go and look at the table of contents. And so when you run a container, we will take all of these ZTalks and we will download them to the server. That is the first thing that happens before a container runs. So these are all now living locally. They're living on my host. When you try and run a file, if it's not there yet, it hasn't been lazy loaded, the snapshotter will work out by reading all of the table of contents which layer it is in. If it was in the blue, green, or yellow in this diagram. Once it's found it, it will then read this Z info, which is basically the location of the file in the compressed tarball. Once it's found it, it will go and get it from the registry, and it will bring it back. And so we kind of have this like loop that goes on while we bring back the files that the workload needs. Obviously, once they have been downloaded, they're there, they're living locally, we don't have to use them again. And it's also worth saying, at the same time that we start a running container, we'll also start a background process to do a full download anyway. And so, if later on in the container lifecycle it starts to try and access lots of files, those files might already be there and they don't need to be lazy loaded because we've done a full download anyway. But it's in that start time, that boot up time, that lazy loading has a really big benefit.
Understood.
Yeah.
Thank you.
So just to simplify a bit, that's how I visualize it in my head, is let's forget about all these nitty-gritties and take 2 steps back. Let's say Sochi index is a hash map of image file name and its location in the address. So if you need a file, if your application needs a file, your snapshotter knows its address in the image which is present in the container registry and just pushes it. That is this super simplified way of saying that it's just a simple hash map of the image name and its address in the container image in the registry. And the beautiful part is you don't need to download that image to get that. It just gets from the registry itself, the particular file.
And we said this, of course, is done in a separate manifest file so that you don't have to start manipulating and changing actual image hashes and mess up your whole previous deployment and whatever you have before. Cool.
Yes.
Yeah, absolutely. Okay. I think maybe it's probably time to start looking at these, start running some containers, start running some tasks. The way that I'm going to do that, I'm just going to bring up a few things. So just to kind of show my environment a little bit. So I'm going to be working in a sample application called Misfits. It's if you've ever used any of the ECS workshop stuff content, you would have come across the sample application Misfits. It's just going to be something I'm going to be demoing and lazy loading in this for this demo. The first thing that you have to do, so I've downloaded Misfits to my local directory, and I've got some Docker files. And there's nothing really exciting about these Docker files. I haven't tuned them in any way. You don't even have to know at this point that the application is going to be lazy loaded. This is a pretty rudimentary Docker file of a Python Flask API. I'm going to turn one of these Docker files into a container image. You've probably seen lots of people build lots of container images before, so it's not too exciting. The one thing that I'm going to do this time, which may be slightly different, is I'm going to use a CLI called nerdctl. And the reason why I've used nerdctl, it's basically a Docker-compatible CLI for containerd. So on this server, I'm using containerd as my runtime. And the way that I interact with it is I'm interacting with it using nerdctl because it means I can use all of the Docker flags, but not actually talk to the Docker engine, and instead talk directly to containerd. So here I did a nerdctl build, the file of the Docker file, the tag of the image, and then the context. Pretty familiar things for those that have built images before. And you can see that I've now built my image. Push it up to the registry, just with nerdctl push. Fine, nothing too different there. I now have an image in my registry, and for all intents and purposes, back to this diagram, I now have the left-hand side. I have some layers, and I have a manifest. And if you've never inspected a manifest before, it's always an interesting thing to do. I personally use a tool called Crane to poke at manifests, but there's lots of different ways you can do it. But if you just use Crane manifest in the URI, you can see that I have a JSON representation of the JSON representation of that diagram. So it's a manifest. It has a config. It has lots of layers, and all of the layers are compressed tarballs. Container image. Okay, so now that I have that, the next thing I need to do is I need to index it. I need to know what files are in what layer to be able to lazy load it. And the way you do that is there's some ways you can automate it, and there's some ways you can do it manually. I'm going to show you how to do it manually first, and then we'll show you how to automate it second, because as we do it manually, we will learn what's inside. But when it comes to your production images, I'd expect you to automate it. And when you do it manually, you use a CLI called the Sochi CLI. Now, the Sochi CLI is in that snapshotter project. So inside of the Sochi snapshotter repository, if you grab one of the releases, you can find the CLI. And the way that the CLI works is you have to have a container image locally. I do. So I have that Misfits image I built. And now I can run Sochi create. And Sochi create is what I did. And resulting what I would do is the Sochi CLI looks at every single layer in that image. And so you can see there was 3, 4, 5, 8 layers in that image. It created a table of contents for 3 of them. It skipped the first 5.
Why?
Yeah, it's a good question. The reason why? Because those first 5 layers were really small. It says the size of the layer here was 244. 244 bytes. And why that is not indexed is because if we think the image layer is too small, then there's no real reason to lazy load it. You can download it very quickly in its entirety. And because it's kind of a little bit of a trade-off between do you want to set up do you go down the lazy loading route or do you just download the full layer? And if they're less than 10 meg, we think it's actually just quicker to download the full layer. And so
Okay.
for those bigger layers and those bigger images that we think it's worth lazy loading. And that's why we've only got...
and I assume the bottom 3 are larger than 10 megabytes.
Correct, yes. Yep.
Okay.
I will say that is a configurable parameter. So if you have a reason to lazy load small layers, we can absolutely do it. And so when you run that Sochi create command, you can put in a minimum layer size of 5 megabytes or something like that. And then you actually have picked up more indexes.
Okay.
But so that's it. I now have a index, and that index lives locally. And so if I do index ls, you can see that I have one. One thing obviously to mention is the index is attached to the SHA digest of the container image. It's not attached to the tag. In container images, tags are like they're just real metadata. They don't mean anything. You can change the tag. You can change the image behind the tag as much as you want. That doesn't really work from our perspective. We kind of need the image not to change, so we create an index for the digest. And if I take a look at that digest, that index, you can do like a Sochi index info command of that digest. I'm just going to pipe that through JQ so it gets formatted nicely. You can see that I now have something that looks very similar to that container image manifest, but this is a Sochi index manifest, and you can see that just from its media type in the config here. But for each of the layers, I no longer have compressed tarballs. I actually have table of contents or ZTOCs.
Okay.
And just for the annotations, you can actually see which container image layer it relates to. And so back to the diagram we had in the blog, you can see that there is a relationship between each ZTOC and its layer, and those annotations are a nice way for us to see that. And you'll also find right at the very bottom of the manifest is this subject field. And this subject field tells us which container image this Sochi index is for.
Okay. Based on the SHA.
Based on the SHA, so 05.
Okay.
And hopefully if you look in the registry, it's a 05 digest. Great.
Perfect.
So that's kind of my local index. And then just for completeness, you can use the Sochi push command and then your image URI again, and that will push the push the index up to the registry. So refresh that, you'll notice I have a few new artifacts.
Okay, so one question. So in other words, you have to push twice. You have to do a Docker push or a nerdctl push to push the actual image itself.
Yes.
And also, and above and beyond that, the Sochi CLI in order to Sochi push, and also to push the manifest and the Sochi index for them as well, correct?
Yeah, that's correct. Yeah.
Okay.
Yeah, absolutely. Now, obviously, we'll talk in a minute about how you can automate those. So you might have an existing pipeline that creates container images like that. That doesn't have to change in the Sochi world, which is one of those key design goals from our side. The image, I didn't change it at all during that indexing process. I had to have it locally to work with, but I didn't have to re-push it to the registry after it was indexed. These two artifacts, that we often get the question, why two? You've just pushed one index. Why do I have two things? Well, the top one, as shown by the ECR console, is my Sochi index. If I grab the URI of that and I use that handy crane tool to take a look at it, you'll see it was what I had locally before. It's all of my table of contents and their layers. So the next question will be, well, what's the second one? Well, the second one is something we call an OCI image index. And if you've used multi-architecture images, you would have come across these before, because they're often used as like an index of indexes. If you had like an x86 container image and an ARM container image, you would then have this image index at the top that would point to both of them. We're using that same concept here, and so there may be a reason for you to have multiple Sochi indexes, and if you did, this is a way for you to do it. And the reason why you might is if you were playing around with that layer size that we talked about. So if I take a look at that, once again, putting it into Crane, you can see that I only have one index there. The other interesting thing about that is that it's got a tag, which is the SHA of my container image.
Okay.
And the reason why that is the case is that we are right now in a position where the OCI, or the Open Container Initiative, are working on new distribution and image specs around how objects relate to each other. And there'll be a kind of a world where we're going to have lots of objects that relate to images, whether that's like SBOMs or so bill of materials, or image signatures, or Sochi indexes. And so the OCI folks are working on a way to standardize how to handle relationships between things. Until that becomes ratified and released, we use this as a way for the client, in this case, the Sochi snapshotter, to know to find the indexes. So it will do a query to the registry for this SHA, which is the container image, and from that it will then be able to find the indexes. If that makes sense.
It does. I have one more question, which actually I was waiting for somebody to ask it. Is it, I assume, as you say, the SHA is a simple JSON file, the same with the index as well, correct?
Yes.
Why is it 4.2 megabytes large? Or is that just something which we are representing in some way with part of the ECR repository?
It's a good question. I honestly don't know the answer, but it is just a JSON file.
Okay, I'll find out the question. If you're looking for the answer, do me a favor, give me a ping. I'll also maybe post it on Twitter. Not today, but it's going to be pretty late, but we'll see. We'll get the answer and answer that for you. Interesting question. Yeah.
Absolutely. Okay. So that was the manual way to create an index. And I wanted to do it because I wanted to talk through the steps. And I wanted to talk through what's behind the scenes. But for most people, I expect them to start to try and automate this. And as Himanshu mentioned, one of the exciting things that we announced last week is an open source project called the Sochi Index Builder. It's a partner solution, so it's on the AWS Partner Solutions GitHub repository. And what the Index Builder does, and there's a nice little diagram of it here, is that every time you push a new image, actually I'll put the link of it in, oh, you already got a link, push an image to ECR, we fire off an event bridge rule to say that a new image has been successfully pushed. And then what we will do is we will then generate an index for the image in a Lambda function. So you have a completely serverless solution to index images. So if you're now pushing images as part of your pipeline, or however you've been doing it in the past, or if you've got lots of teams that are pushing images in lots of different ways, you don't have to go around and educate them and tell them what the Sochi thing is and tell them what the Sochi indexes are. You could just put the serverless solution in, and you can be generating indexes.
And as we say, magic happens in the background, and the index and manifest are created for you, which is awesome.
Yeah, absolutely.
I love magic.
So just to kind of see that in action. So in my the way that you deploy the index builder is there's a CloudFormation template as part of the GitHub repo. So there is a crate stack way to do it. And I have that deployed inside of my account. So I have the index builder deployed. Sorry, it's just moving my tables around. The one parameter that you can put in to the index builder is what container registries should you listen out for. And so there's like a bit of a regex here. So you can listen out for multiple repositories and tags. So in my particular example, I want this event bridge rule to be looking out for anything that goes to the Misfits Index Builder repository, but they can be tagged anything. There's no specific tag in mind. And so if I go back to my CLI, and actually I will show you just to show you that there's no smoke and mirrors. If I have the index builder repository, it has no nothing in it. What I'm going to do is I'm going to build the image again, just with that index builder tag. And then just do the push. What I will have now is I will have that image, and behind the scenes, the Lambda functions should be doing their thing. Just to kind of see what that actually looks like, there's actually two Lambda functions in here. The first one is checking my regex, it's the image filter. And then the second one is generating the index. So if I look in the logs for the first one, which is the filtering, it would have something like, successfully indexed the image because it has met the right tag. And then if I look in the second one, you'll see something very familiar here. You'll see layer ztalk as it goes all the way down, because now behind the scenes, I will have generated an index and pushed it to my repository.
That's very nice. I love that you don't have to do all the work for yourself. It does it automatically, and you don't have to change anything in your pipelines.
Absolutely not. No, it's a really, really nice solution. Okay. So that's the Sochi side. A lot of that is the indexing images. I then want to quickly move on to the Fargate side, because the next question will be, okay, now how do I run these images? What's new? How do I do it? And the exciting part really is it's a little bit dull. And by that, I mean, and dull in a good way, because, yeah, that came off wrong. But the reason why I say that is because there is no flags or anything different you have to pass into the task definition. And so the demonstration that I'm going to do is I'm going to run some tasks that are going to do some PyTorch training. So PyTorch being the machine learning training. And it's a great use case for Sochi because it's a really, really big container image. It's a container image that's sort of like 5 gigs in size. And so it's a container image that would traditionally take a couple of minutes to get going on Fargate. But you'll notice in this task definition that there is no, Sochi equals true or anything like that to lazy load this on Fargate. The way that we've implemented it is that if Fargate detects a Sochi index, it will lazy load the container image. If it doesn't detect the index, it won't lazy load the image. So the way that you enable it is you push the index. The way that you disable it is you delete the index. There are a few kind of caveats that for example, if you had multiple images in a task, all of them need to have an index for it to be lazy loaded. But apart from that, there isn't anything really else you have to do on the ECS side. It's available in all regions. There is no additional cost to lazy load container images on Fargate, and you don't have to recreate clusters or capacity providers or anything like that. It's just there, ready to go. Okay, so let's start some tasks. And the way that I'm going to do it, I'm going to run this PyTorch demo, and I'm going to do a bit of a before and after. So in here, I have a PyTorch no index container image, and it's in its own repository because I didn't want there to be confusion about which one's running. And obviously the clear thing here is it's just a container image. There's no indexes here. And you can see even compressed, it's over 2 gig. And then I also have just a Python training one, and that one has been indexed, and you can see that there is a Sochi index in the repository. To start these, what I'm going to do is I'm just going to use the AWS CLI to do it. and forgive me for some copying and pasting going on here, but what I'm just going to do is I'm just going to clear my screen, and I'm going to register the task definition. That was task.def.json, which was the one I was showing, which is just got the container image and a command to run an example training. It's one of the examples that's in the PyTorch repository. I'm also then going to generate I'm also then going to register another task definition. This second one is going to be using that no index image. So it's not going to be lazy loaded.
Just want to make you aware we have another 14 minutes. So it's
okay.
Cool.
That's fine. Yeah, that shouldn't be too bad.
Because we are speeding up the loading of the images now, so it'll be all faster.
Absolutely. Well, I'm not going to wait for them to be trained, if that's what you're asking.
That's okay.
Little time. And then to start the containers, I'm just going to do the ECS run task. So when you start tasks on ECS, they can be long-running services, or they can be just a run task, and that will run to the container's completion. And so I'm going to do one of those. And so it's an AWS ECS run task. I'm going to run 2 of them. I'm going to run them on Fargate. There is my task definition on the cluster default and with the networking params. And so there is the lazy loading container images. And just for completeness, I'm going to start 2 of the non-lazy loading images. And so now I should have 4 tasks on an ECS cluster. And there we go. And you can see that just from the task definition side, some of them have indexes, some of them do not. And what I expect to see, well, there you go. These ones started very quickly. They're already running according to ECS. The non-indexed ones are pending. And they'll be pending because that's got to do a full container image download. It's got that full 2 gig image coming down, whereas the lazy loading ones would have downloaded the indexes, and then it would have waited to see what files needed accessing at startup, and it would have lazy loaded what was being asked for at startup. Okay.
Still pending.
Yeah, it will. I'm just going to wait for them to get running, and then I'll just to show you the time difference between the 2. But while that's booting,
I have one question which I think will be useful. So I assume this works. There's absolutely no dependency on the operating system of the image. So in other words, for Windows image, which are usually significantly bigger than Linux ones, this will also work.
Not yet. This is available today only on Linux tasks.
Okay.
So only on the Linux tasks. Today it works on x86 Linux tasks, but very soon it will also work on ARM Linux tasks as well. You don't have to do anything different to your existing images. You just have to index them. So there's no rebuilding going on. I'm trying to think what other common questions I get asked on the Sochi side.
It works only for Fargate today, correct?
Oh, yes, that's very true. Yep.
So Fargate on ECS. What about ECS on EC2? Is that something which we are thinking about currently in the service team?
Yeah, absolutely. So the repository is open source, so anybody can download the bits and start their own snapshotter. The caveat being is that it will only work with the containerd runtime. Okay. So you have to be running the containerd runtime that is starting and stopping your containers, and then you can lazy load them with the snapshotter. There's a couple of small paper cuts we just need to close before we can work with Kubernetes and containerd. But in the kind of the grand scheme of things, the only dependency that we'll have is the runtime. Okay. So yes, it only works with ECS Fargate today. It doesn't work with ECS EC2 because EC2 is using the Docker engine. But there is work going on the Docker engine side to use snapshotters, and when they get there, then you'll be able to use lazy loading with the Docker engine as well.
Nice.
Cool. Okay, so I have all of my tasks running. And just for completeness, I'm going to run a quick script that will describe the tasks. And while it describes the tasks, I've just said go and grab the started at and the created at timestamps. And these are timestamps in the ECS API that will tell us when they initially created the task and when that task moved from pending to running. And I'm doing it for both task families. So I'm doing it for the index task family and the non-index task family.
Okay.
So if I run that real quick, you should see that I have my index tasks at the top, and they were created at 47 minutes, 23 seconds, and they were running at 47 minutes, 42 seconds. So not that long.
30 seconds.
Yeah.
Less than 30 seconds, 20 seconds.
Whereas the non-indexed image was created at around the same time, so 47:34, but took a couple of minutes. So it didn't start till the 49:29. So that was the 2-minute start time compared to a 20-second start time.
So to me, this is actually very interesting because here we can actually see that without Sochi, the most part of your time when launching tasks in Fargate was actually waiting for the image to be pulled. It's not the fact of how fast the actual instance underneath starts and is ready to run and accept the container, which we say is pretty much according to what we're seeing over here. And of course, it will vary depending on the task size, which region, what time of day, a number of other things which you're running. But it's 20 seconds to get an instance up and running and ready to accept a container. And without Sochi, that's the same 20 seconds, but it's going to take another minute or two to actually pull the image and then only start. So most of the time it's actually spent at the pull time, not at how fast the Fargate task starts.
Yes, that's correct. Yeah. And
interesting.
Yeah, and so there is definitely that relationship between the time to start a Fargate task and the image size. And one of the things that we like to call out is that Sochi is most effective for larger container images. If the container image is less than 250 meg, then they actually pull super quickly anyway, and there isn't much of an advantage of lazy loading them. There may even be a penalty just to download the index and set up the fuse file system.
Okay.
So really, container images bigger than 250 meg is when you really start to see some benefits. And as you say, the bigger you get from there is the benefits will scale linearly in terms of the comparison between indexed and non-indexed. And so when you think about use cases, people that do machine learning training, big data processing workloads, analytical workloads, ETL, batch, all of those things where people put a lot of models and a lot of dependencies into the image is when we got to see some real big benefits. If you've got a lightweight Rust API that's a couple of meg, lazy loading probably isn't for you. But
using an Alpine image of 20 megabytes is probably not a good idea either. Okay, perfect.
Yeah. So that's everything I wanted to show demo-wise. Himanshu, have I missed anything?
No, you were bang on everything. Yeah. So it was a very interesting demo. So I think you covered everything. So let's talk about, as I mentioned in the starting, I mentioned some of the numbers. Let's maybe have a look at customer testimonials for that. I just let's open the launch blog.
Yep.
So as I mentioned, Sochi was open sourced last year in September. Fargate started its private preview sometime in end of Q1, end of March, and for the 3 months we had a private preview going on, and a lot of customers tried it out. And and first of all, thank you so much for all the customers who tried it out and gave their feedback. Their feedback is very valuable to us because that helps us improve our product even further. And the response has been overwhelming. Customers have really liked Sochi, and these are some of the few testimonials that customers shared. As you can see, in case of Autodesk, it worked like it was more of they also used the Sochi Index Builder solution, and which was very easy for them to deploy. They saw 50% improvement in the time-sensitive workloads which they had. Similarly, Flywire also had 50 to 60% improvement, and as it also corresponds to Olly's comment that larger the image, better the startup improvements. And that's we can see that for the larger images of 750 megabytes and more, they saw 60% improvements, and for their smaller images they had 50% improvement. And the one interesting thing that Flywire shared was they have multi-step deployment pipelines, which very common in the CI/CD pipeline, that we have a small chunk of building, and then it moves to the next chunk, next process. So similarly, they have sophisticated multi-step pipelines, and since if every task, smaller piece, basically if every node of a DAG takes a lot of time to start, so eventually the end-to-end deployment or end-to-end building takes a lot of time. In their case with Sochi, because every node of the DAG or every task of the DAG was coming up fast, so the overall time to build their process was pretty much improved by Sochi. And this brings us to the third customer, Virtuoso, and for them it was a 40% improvement. And they also it was very easy for them to use Sochi. One thing that I would also like to mention is, which we've already covered, that it's a very safe rollback kind of a system, that if you don't want to use Sochi, just delete the Sochi index. That's it. You're good to go. And that's the magical part that we say, that you don't have to change your ECS task definitions. You don't have to change your images. You don't literally have to change anything. You can either use the AWS Sochi Index Builder and take everything out of the box. The magic happens for you. Or the other way is, you can actually, if you're interested, you can use the Sochi CLI, integrate into your CI/CD pipelines, and then use it that way. So yeah, so that was the summary of all the things that we have discussed.
Awesome.
Anything else you want to share, Olly?
Mesh is on mute.
Yeah, I'm on mute for some stupid reason. I don't know why. Before we close today, I wanted to ask one more question. It currently supports Amazon Elastic Container Registry only today, or other repositories as well?
Yeah, that's a good question. So Sochi itself, the open source project, they've been doing some testing, and there's a list of repositories that we've been testing against that can store indexes. And because we're just using OCI images, it's looking pretty good. The thing I will say is that today, when you're using Fargate, Fargate today can only lazy load from private ECR repositories.
Okay. So what's planned for the future? I heard we talked about the fact of on ECS, on EC2, EKS. I heard you mentioned ARM somewhere as well.
Yeah. We are we're currently working on the ARM support. That's another major customer ask, and we would be rolling out that support soon, hopefully in August itself. The other thing that we're working on, we're trying to even make it even faster for the application to start. We are doing some research stuff. Our engineers are doing some research stuff on it, and we'll be sharing some interesting things about that very soon, but still not concrete. But the TLDR is we're trying to improve it even further, make the applications and task scale out even faster. The other thing is, right now you have, for all the images within your task, you have to build Sochi index and push it to ECR. Otherwise, it will fall back to the normal eager pull, and where the entire images are pulled before the application starts. So we're working on a solution where, let's say you have 3 images, and one, the main container image, the couple of others are sidecars. So in this case, you can just choose to build the Sochi index for the main image, and leave aside the sidecars and don't build a search index. So it's a kind of a multi-snapshotter mechanism where some of the images have search index and others don't, and you will be able to leverage lazy loading for your beefier, bigger main image. So that's something we're also working on. Hopefully by in a few months, we would be rolling out that solution as well.
Cool. We're pretty much over the end of our hour, but since we're not on Twitch, so we can go for the last few minutes. Is there anything else you would like to share or add with us before we close today? Olly?
From my side, honestly, go try it out. Hopefully it's come across quite painless. Hopefully you can see how easy it is to create indexes through the index builder, and how the fact you don't have to change the images, or you don't have to change the task definition, you can lazy load straight away. So in a test and dev environment, go and try it, go and lazy load some images, and let us know how you get on. As Mesh has put in the link, there is the GitHub roadmap place where we track feature requests and things like that. So feel free to give us feedback if there's something that Snapshotter or Sochi is not doing that you want it to do. Let us know.
Thank you. And Himanshu, anything else you would like to add before we close today?
Olly literally said everything I wanted to share, but but let me add a couple of things. You can also ping on this YouTube video as well. I'll be watching it out for feedback and requests, as GitHub pages are very useful for us to hear customer voices and improve it further. I'll reiterate the fact that it's an open source project. Feel free to contribute to it. We would be more than happy to collaborate with you and take this technology one step further. We have very interesting stuff coming up. As we mentioned, we're trying to improve it even further. We're trying to find patterns how we can improve it. And your comments, your feedback would be very helpful for us to improve it further. EC2 is another thing. AKS, we have already discussed these things that we're working on. But yeah, just go ahead, try it out, use the AWS Sochi Index Builder. It's fairly straightforward. Within a few minutes, you would be able to see the differences. If it works for you, then you can let us know.
Perfect. And if you have any other questions, feel free to reach out either to Olly, to Himanshu, or myself. My Twitter handle is here. And if you want to get in hold of them and you don't know how to get them, ping me and I'll pass on the details without a problem. I want to thank you for joining today. If you haven't hit the subscribe button on our YouTube channel, please do so. We appreciate your support. I also want to point out that we'll be having another Containers on the Couch session on Thursday at 12 p.m. Pacific time, this time with more ECS and Apache workflow. Will be an interesting session. So please don't forget, put it in your calendars, join us, and thank you very much, everybody, for joining. Thank you very much, Olly and Himanshu, for an amazing session. Thank you so much.
Thank you so much.
Cheers, guys.
Bye.